Thank you for the reminder to record, Chen Chen. So yeah, I'll recap again. We can make capture groups at any point by slapping parentheses around any regex pattern. And those groups are captured, those unnamed groups are captured with the search object .groups. And we just get back the plain strings that they return. To review naming our capture groups, instead of just putting parentheses around a regex, we do question mark parentheses, question mark capital P, angle bracket around the name, and then whatever regex we're going to do. Anything that's not in parentheses, like the colon / in this place, is not going to be captured by any one of our capture groups. So the dot between the domain name and the .com or the .org, that dot is not going to be captured since it's not part of a group. Okay. And what we can do with these named capture groups is capture and name certain chunks of our regex, of our patterns in our search string. And this is really powerful because instead of just looking for the protocol in one search and the domain name in another search, and then the .com or the .org or .edu in the last search, we do everything with one regex search. And if we're doing these named patterns or unnamed, really either way, I want to acknowledge that the \W+ is very, very permissive, right? That's going to capture every alphanumeric that's one or more characters. But because we have it following the literal colon // we're not going to get any false positives and grab any one or more letter, string of characters of alphanumerics. So see how having the HTTP or the HTTPS, that S is optional, in front of the colon / means that whatever regex you write here can be a little less perfect, a little less than the best possible regex in all possible cases, because we already know that regex is following that literal pattern of colon // Does that make a little more, does that make some sense? That like if we were trying to capture every .com without the protocol, that would be harder regex to write. But if we have the protocol and a colon // we can, I don't want to say be lazy here, but it actually just gets to be an easier problem. And we can have as many of these named groups as we want, right? In this case, I have 3. And at any point, if one of these groups is optional, like this whole group on the .com, on the top level domain, if you have a question mark right after that, that means it's optional, right? So we really start thinking about our regular expressions kind of almost algebraically, right, as each individual expression. So once you get that match object, .groups gives you back the raw strings, but the really powerful way to get data out of those groups, especially if you've gone to the trouble of naming them, use group dict for group dictionary, and you get back key, value, key, value, key, value. And that's really quite powerful. Another thing that we can do if we don't want the entire dictionary of all of the named capture groups, the group function can accept in a string argument of the name of that capture group, and we can pluck just that one capture group name out. Okay. So it gets a little weird to see the question mark P inside of parentheses and then the angle brackets, but to break this apart, the parenthesis is making the group. The question mark P is a way of telling the regex parser, hey, the next angle bracket, don't treat it as an angle bracket, treat it as whatever is in the angle bracket is the name of your capture group. Okay. Where this can take us is after matching a group or two, and I highlighted this a minute ago, but after matching, if you have a search that's matching multiple groups in one string, the need to be highly specific with your subsequent groups, unless there's a lot of ambiguity, starts to decrease. So like, for example, parsing out these logs down here, it could get a little hairy to write the regex necessary to match, oh, I don't know, the user agent string for somebody's browser, right? There's a lot of options in there. But if you've already captured the other pieces, the other groups, and I would encourage you to name them, then your regex can get a little less specific, and that you're not going to have any false positives, or much less likelihood. So in that way, you're relying on the regularness of these forms. And when I say forms, I mean different kinds of patterns. These logs right here these are web logs, and I'm not going to solve these for you right now because they're actually part of the exercise. But I want to kind of inch through these together with y'all, and talk about some of these different components, some of these different pieces, because this is one of the exercises. Let me make my screen a little bit larger so I can see y'all. Okay, so web logs look a lot like this following string a lot of the time. And I want to introduce y'all to a couple of pieces of these web logs. Get and post are what are called HTTP verbs. Those are ways you're sending or requesting data over the internet. And a get is a download request, and that's like when you click on a link on a web page, you're sending a get request to a server. When you navigate to codeup.com or python.org, you're sending a get request. It's a download request. When you're submitting a form, like a credit card authorization form on a web page, or you're logging in, that's almost 100% of the time that's a post request. So get is a download, post is an upload. And regardless of what kind of web servers you might use, it's important to know when your visitors are trying to download something or trying to upload something. The next little piece of the log is usually the endpoint. So it's what they're trying to download or where they're trying to send their upload. Okay, so notice these are pieces of a URL, /API, /v1, /sales. And then that question mark, it is setting up something called a query string, where we will have page numbers, or if you go to YouTube and you look up a video, the query string says V for video, and it says V equals, and then you have some alphanumerics. Logs are very, very useful with timestamps. So parsing through this, again, these specific logs are part of the exercise, but our timestamps here are day, month, year in this specific format. Then you've got the time zone, followed by the version of HTTP. That's this HTTP /1.1. And then these curly braces right here, these are the HTTP status. Have y'all seen the HTTP status dogs and the status cats before? Okay, cool. Y'all have made it through a lot of material, which is really awesome. And then to the right of the curly braces, you're seeing the number of bytes transferred or uploaded. So this is downloading about 0.5 meg, 510 kilobytes, 42 bytes uploading. And then this string that's to the right of the number of bytes, that's called the user agent. Anybody tell me what a user agent is, or what that means in plain English? Cool. I'll get to share that with you then. A user agent is when you send a request to a server, you have to send it through some sort of client. So when we talk about a browser, your browser is a client. It's a web client, as opposed to a server, right? This whole client server architecture. If you were using a mobile device, your mobile device's application would either be, the client would be a browser, or like a banking app would be the client. In this case, so almost all the time, your client is a browser. In this case, we can see that somebody's using the Python requests library as their client. So that means whoever sent this request didn't send it through a browser, they sent it through scraping through the Python request library. And I think y'all have used the request library to hit an API before, right? I think in the time series exercises. So the Python request library is identifying as your client. If you were using like a Facebook app, your Facebook app itself would be the client. And then if you're using a browser, you get this big, long, crazy looking nasty string, which is called the user agent string. And it can be a little confusing because it lists, see how it lists Mozilla here, but then it lists Apple WebKit. Mozilla is Firefox, Apple WebKit is Safari. So what I would advise you to do if you ever have to track down user agent strings is just go to do a little Google search for a user agent string parser, and you paste this in. See how it says Chrome also? This doesn't mean that they're hitting this with both Apple and Firefox and also Chrome, but you put this user agent string in a user agent string parser, and it'll tell you which browser they're using. And if you really need to dig deeper, this is a little bit outside of the scope of, or this is outside of the scope of the exercise. But if you end up doing any kind of forensic investigations, or you're doing security work with data science, you might need to figure out like what type of operating system somebody's using, and that you can get some of that information from a user agent string, which is pretty cool. And then the right-hand side number that's outside of that user agent string, that's the IP address. So that's where they were reaching to your server from. And IP addresses are, there's public IP addresses, and then there's private IP addresses. Private IP addresses are like your IP address on an internal network, like Wi-Fi in your home. And then you'll have a public IP address that's what you look like to the rest of the internet. So looking at this, and I'm not going to do this exercise for you since it's part of y'all's, we would probably name a capture group for each one of these sections. So the first section, you're either going to have get or post, because browsers only talk get and post. There's a couple of other HTTP methods that like mobile devices and can use, but browsers just do get and post. Then you would have to make the regex to capture the endpoint, the regex to capture the date, the regex to capture the bytes, the regex to, or the HTTP code, right? And after each one of those named capture groups is where you write the regex inside of the parentheses to capture what you're after. Let's take a look at this and do a concrete example with some emails. So I've got a couple of different email addresses here, and I'm going to leave a little bonus for y'all. So right now I have firstname@company.com, firstname@company.com, firstname.lastname@company, firstname.lastname. And then I have a couple of bonuses here where we have a first name, middle name, last name, and then I've got not just a .com, but I've got 3 parts of the domain. Okay, so let's take a look at this. I've got a list of email addresses, and if I needed to parse out things like the first name, the last name, the domain, and the top level domain, let's take a look at what I'm doing here. And I want to introduce y'all to another flag. The first regex flag that I shared with you was called re.ignoreCase. And it's at this point in the game where I want to introduce you to the verbose flag. And here's what it's going to do. Would you say that it's easier to read the regex broken out by line as opposed to if we put everything on one line like this? So here's, if we were to write out this entire regex right here, you could get rid of the re.verbose. But what the re.verbose is going to do is it gives us line breaks in your regex. When I say line breaks, I mean these hard returns. re.verbose will ignore the line breaks, those new line characters, and it's not going to break or change how your regex works. Otherwise, you have to write everything perfectly in one line, which is kind of a hassle. right? I don't want y'all to have to live like that. And then let me pull up the Python regex documentation. I want to find something for you here. There's a couple more flags. Ignore case is one you're going to use a whole lot. Multi-line you might use. Some of these you might want to check in certain cases, but verbose is helpful. Ignore case is very helpful, and you might use multi-line. And there's some more in there, but it might be a little while before you need them. So verbose is going to be your friend here. Now check this out. What we can do is remember our group dictionary method. If we call that on every single search object, we will get every single capture group along with its name as a dictionary with key value pairs. And we can put that in a happy little list comprehension here. And now we have first name, last name, domain, top level domain for all of these email addresses. Now this is going to fall apart on the 3 name and the 3-part domain name. Those are a little bit of a bonus for y'all. But what's nice is if you were to say, make a variable out of that, instead of just having a list of dictionaries, well, my friends, pd.dataframe on context, and you have a happy little data frame, right? Cool. So however complex and your regex is going to get, it's probably going to be more complex than just one or more alphanumerics. That's going to go inside of the parentheses of your capture group to the right of the angle bracket. I see a question from Jess. Go ahead, Jess. How can I help? What's on your mind?
So I noticed you have like a lot of the question marks saying like, hey, this is optional.
Mm-hmm.
What do you do to anchor it? Like if you have optionals at the beginning and end, what do you do to tell it like say we were doing phone numbers and you had numbers at the beginning and end were optional, how do you tell it when to start?
Oh, great question. In that space, what I'm going to rely on is other patterns in the URL. Like for instance, the @ symbol in this email address. And I realize that my named pattern here is a lot less sophisticated than that regex I showed you all at the beginning of the lesson, right? That was like a 90-character regex that looked like wizard speak, right? Looked like part of a spell book. But if you've got pieces of the pattern, like I know I'm going to have HTTP, the S is optional. Like you always have a protocol in a URL. I'm going to anchor myself around the :// and we might have URLs like I'll give another example here. I'm going to copy this and see if I can't answer your question again. Like what if we had http :// What if we wanted this first piece to be optional, but we also needed the regex to work if that wasn't there, right? So we would need to work for codeup.com and ds.codeup.com as alike. Well, in that case, what I would do, just to make things easier for me to read, I'm going to do the re.verbose flag, and I'm going to start breaking this up and put each different component and see how I'm visually putting the invariants, like the things that are not going to change on their own line, almost as a visual reference for myself. And so now I can say, well, if I want to have the subdomain named capture group, and that's the DS part, that would be the subdomain, we will say, I don't know how many characters it's going to be. It'll be alphanumeric. but I could make that subdomain optional and see how I'm putting a question mark, not over a piece of the pattern, but over the group itself. Because whenever you have a question mark, well, a question mark outside of naming it, it makes that group optional. And then let's see, I need to terminate my string here. Here we go. So that's going to work with the ds.codeup. And let me see. Oh, I needed to add a literal period here.
Yeah.
Yeah. And since that literal, if the subdomain doesn't exist, that literal period must also itself be optional too. But I don't want the period to be part of the subdomain component. So, and then we'll do the group dictionary. And then I can have the protocol, the subdomain, the domain, the top level domain. And then with the same regex, but different different subject search, because that period, oops, group dict. Oh, it's not finding anything. That's interesting. My match is empty here. Why would my match be empty? I have the colon // It's the same variable here. Nothing like a little live coding and troubleshooting. My .com. So the .com is required. The period for that is required. The domain is required.
Do you need to put RE verbose in there again? Because you have.
Oh, I totally do. I totally do. That is a wonderful catch. Yeah, like gold star, super duper pile of cool points, Jess. Because I had a new line character, this regex here was searching for protocol new line character : / new line character. So yeah, you are absolutely correct. Yeah, right there. And then the group dictionary is going to show. Oh, I have a little bit of a breakage here. You see that where coda the domain is P. Let me see.
Because it tried to make a subdomain and a domain, right? Like it tried to answer both those questions.
It attempted to. Let's see.
So this would be a case where we need to add an anchor point essentially to tell it, hey.
So I put the caret is going to say the string starts with the protocol. I can put a $sign at the end to make sure it ends with the .com. I'm going to try that out. And that's not forcing it to work the way I wanted. Let's see. This is going to work for, yeah, java.codeup. It's going to fall apart there. Let me just a sec, think. Same.
But this would be something where then you learn, like, I need another anchor point or something like that, right? And you just kind of play with it. Okay.
Yeah.
And I mean, it still answers my question. I just need to know there are ways to anchor it then essentially.
Yes.
Okay.
And my answer is usually it's going to be contextual. And like if I know I'm going to be looking for java.codeup or ds.codeup, I could say we might add in like the number of characters here to kind of create another place to get a handhold. It's bothering me. It shouldn't stop at the U, at the letter U on the subdomain. But yeah, usually you're using other pieces of the pattern to help you there, to help you get your footholds.
Can you put if statements in there?
Not if statements like Python if statements. I mean, really the question mark is making something optional.
Mhm. I was
And
thinking if it wants to fill subdomain, if you could do something like if subdomain, then like the period's like optional kind of thing, or combine subdomain in the period some way so that it knows to skip one, skip both.
might be able to do a parenthesis. See how I'm not doing a named subgroup there, but I put parentheses around
Yeah.
both of those.
Mhm.
Yeah,
Yeah. Yeah. We need to combine, okay, the subdomain and the period. Okay.
right.
Okay.
And-
This is making more sense. Thank
And
you.
yeah, and since this outer group was not named, it doesn't get captured with the group dictionary. But if for some reason you needed it, like really needed it, you could do group. And oh, what is it? I forget the function to grab all the groups. I think it's just, oh, it's just groups with an S.
Okay.
So the like you can mix and match between the named and the unnamed. And in this place, I'm using an unnamed group to capture this whole structure of the subdomain.
Okay.
But I don't need the period as the subdomain to be part of the subdomain. Yeah.
It's just kind of an anchor point of optional.
Yeah.
Okay. Thank you. This makes more sense to me.
Oh,
Thanks.
cool. Yeah, great question. Great question. Thank you for your patience while I sorted out what I needed to do there. And I like how it answered like another facet of your question, right? That's cool. Cool. There are more examples at the end of the curriculum about using multi-line, ignore case, and verbose. Also, a couple more examples of using substitution. It's not that challenging. And a couple of different examples on using using unnamed and named capture groups, but I like this one. So what I'm going to do is save this and send it up to GitHub for y'all. And then you can grab a copy of it. And then I'll have all of our extra work. And yeah, we can stop the recording.